So in probability, sometimes we have to go and do comparisons, okay? It's one of the key things that you need to be able to do in order to understand how probabilities work, right? So let's go and talk about my favorite thing, the 649 and lightning. Okay, now, so when people sit down and do the math for the Lotto 649, they actually tell us that the probability of winning something in the 649 is approximately 0.0000715. Now, that's not a percentage. That's the decimal representation of our probability. Okay, so the probability looks like it's very small. Now, the experimental probability of being struck by lightning is approximately 1 in 500,000. The question for you is it, which is more likely to happen? Getting struck by lightning, which is 1 in 500,000, or is it more likely to win the lottery? Some people say that lotteries are taxes for the uninformed. We're going to explain that before the end of today's lesson. Okay, now we'll get back to that. Now remember that the probability of something is the number of favorable outcomes divided by the number of possible outcomes. So if you think about it, with respect to the lottery, we've got the 649 here, which is the number of winning tickets divided by the number of people that are playing. Okay? And that will tell us what the probability is. Now, but you got to remember, this probability is a fraction. Now, I just want to make sure that I remind you that we've already studied other probabilities, okay? When we were working in the past sections, we took a look at probabilities of using the same formula but modifying them. Now, this next problem here is an example where we have the experimental probability of breaking up ice in the river on particular dates. And you'll notice that I've got the number of times that we wanted divided by the number of years studied, right? So that's like very similar to what we have here for our original probability. Another example would have been the probability of getting a card that offers a discount. So that would be like if you were getting a roll up the rim to win. If you knew that there were 1,000 possible cups, but then there were a certain number of cups that were labeled for winning, we could figure out the probability. Remember, the probability is nothing more than just a ratio, right? Now, before we move on, I want you to understand this. When you go and take a look at the theoretical probability of the Lotto 649, okay, you'll notice that you have this as a decimal. We can turn that into a percentage, right? We can also turn this thing into a percentage. And what you do find out is that it's more likely to be struck by lightning than to actually win the Lotto 649. And that is using a comparison of ratios. And that's why when they say that some lotteries are taxes for the uninformed, is because the uninformed don't know what the probabilities are for each type of event. One being the lightning and one being the lottery. One is easier to get than that. And you'll notice that lightning is more likely to happen than winning the Lotto 649. So if you put your money in the 649, you're going to lose your money. All right, so we're going to spend about 5 minutes doing 3 concepts. And here we go. So years ago, you studied ratios and percents, right? And you studied ratios to help you understand what fractions and percents were, right? Now, remember that a ratio can be written as a percent, right? The other thing that you got to understand is that probabilities are ratios or fractions. And in knowing this concept, you know that they can be written as percents. So that means a probability can be written as a percent, which means that we can take that information and we can actually compare the different probabilities, i.e., what is more likely to happen. So let's go over some of the basic skills that you'll need for today. So basically, some of the skills that you need are the ability to compare fractions and ratios. Sometimes you have to use reductions for comparison, or we need to change those fractions into percents, and we'll do that right now, and then I'll let you go on your work.
So what we're going to do right now is we're going to take a look at the ability to compare fractions or take a ratio and change it. All right. Now, one of the things that you studied a while back was ratios, right? So if you heard of something like, say, this, if I had, say, 5 out of, say, 16, right? Okay. Or something that could be written as 5 out of 16. Okay, so that would be our first example. So you can say that 5 over 16 is the same as saying 5 out of 16. So if you ever see that, you should be able to change your thing into a ratio right away. Now, let me show you another thing that you could do with these ratios. So let's say I had 5 out of 10. I could take 5 out of 10, take that, and then write that as something like this. I could write that as 5 over 10, couldn't I? Now, the fact is 5 over 10 can be changed into a different fraction because 5 over 10, both the 5 and the 10 can both be divided by 5. So that gives us a final answer of, say, 1/2. So you could say the following: 5 out of 10 is equal to 1/2. So you should be able to do something like this in your next assignment, your next bit of homework assignment. Now, let's go and take a look at the next concept. Sometimes we have to change a fraction into a percent. So because we just came back from March break, I'm actually assuming that you don't remember that. So imagine I have something like this. Okay, 7 out of 10. So I could say 7 out of 10 could be written as 7 divided by 10. Now, that is the same way we would write our percentages, right? Or our probabilities. Now, what we're going to do is we're going to take this thing and turn it into a percent. Now, or we could write this as a percent, okay? Now, if we go and turn this into a percent, all we're going to do is we're literally going to take 7 divided by 10 and multiply by 100%. Okay? Now, by multiplying this thing into by 100%, what you're going to get is a final answer of 70%. Now, that is the cool part. So if I said for A, in this example, I had 7 out of 10, and I had B is, say, let's go 12 out of 25, I could sit here and go, okay, I don't know if this fraction or this fraction is bigger, right? But what I could do is I could turn this into a percentage. Now, since I'm not sure if 7 out of 10 is bigger than 12 out of 25, I can turn this into percent, couldn't I? So what I'm going to do is I'm going to say, all right, well, I've got 12 divided by 25, and we're going to multiply that by 100%. And that gives us a final answer of 48%. So that means that this one, the 70%, is bigger. So you could use that in your probability type calculations when we're trying to figure out which thing is bigger, which probability is more likely to happen, or which probability is less likely to happen.
Now let's go to converting a fraction into a decimal. And here we go. So imagine we have to change a fraction or a fraction probability into a decimal. Imagine I have these two different probabilities, and we're going to try to see which one is more likely. Now, I have 2 out of 5 or 4 out of 20. Now, if I want to go and compare them using decimals, so this is a new way of solving it. The first time we figured out what the percentages are. So now we're going to figure out what our decimals are. To do that, we're going to take a look at 2 over 5, and all we're going to do is we're going to write it as 2 divided by 5. Now, 2 divided by 5 is just 0.4. Now, when you go and calculate 4 over 20, we do the same thing. Now, you'll notice that this one, 0.25, has 2 decimals, right? And because it has 2 decimals, we want to be able to compare the other decimal for 2/5. So all we got to do is add a 0 to our decimal, and now we have a comparison of the same decimals. And the best part of this is that the moment I can compare the two decimals, I can say which one is more likely. And we can say 2 out of 5 is more likely because 0.40 is bigger than 0.25. And we're done. Now your work has been posted online. Good luck.